When an ionic compound dissolves in water, it breaks apart into the cation and anion. This is also known as dissociation, and when we write out the equation for this, this is sometimes known as the hydration equation. So when we write out a hydration equation for a strong electrolyte, on the left side we have the undissociated ionic compound, and ionic compounds are solid at room temperature. Then we have the arrow and the water, which is a necessary condition, and then it breaks apart into the ions that form it. Magnesium, which has a +2 charge, and 2 chloride anions, and each chloride has a -1 charge. The phases here are AQ, which means that each of these ions are completely surrounded by water molecules. Now, it is important that this is balanced in terms of number of atoms, so 1 magnesium, 2 chlorines, 2 chlorines, and it's also important that it is balanced according to charge. If we look on the left-hand side, our compound has no overall charge, and if we look on the right-hand side, our products, magnesium, have a +2 charge, and we have 2 chlorides with a -1, so that is equal to an overall charge of -2, and 2 plus -2 is 0. Both sides of the arrow don't have to be 0, but they do have to be equal to one another. So when we are writing a hydration equation for a strong electrolyte, the ionic compound is going to be solid. We have the arrow that goes just in one direction. We have the cation, we have the anion, and both of those will be in the aqueous or AQ phase, and the total charge will be equal to the charge on the left. And if we start out with a compound, that will always be 0, and this overall charge must be 0 as well.